This video takes a look at Module 2, Lesson 13, converting between fractions and decimals using equivalent fractions. So down here on the left, we have vocabulary word decimal, which we'll use. We have the strategy for creating equivalent fractions and fractions. So you should have some comfort with these three as we move through this lesson. So today you guys are going to convert positive decimals to fractions and fractions to decimals using equivalent fractions. You know you have this when you were able to fluently convert fractions to decimals and vice versa, so that means the other way. And our standard is the start of 7NSA2D, convert a rational number to a decimal using long division. Known as a decimal form of a rational number, know that a decimal form of a rational number terminates in zeros or eventually repeats. So we're not diving all the way into this standard, but we are getting a start here. So before we jump into example 1, just a reminder of where decimals are used in the real world. The most common way you see decimals is probably through money. Often, you go to the store and you need to buy something and it's written in the form of money, right? Also, you may see it in like a measurement system, specifically the metric system. Now, in terms of fractions, a lot of times you see fractions in recipes, right? It will say like you need a half cup of something or 3/4 cup. You may also see it in carpentry or when you're an architect. Those are ways that fractions are generally used. Now, measuring cups, for instance, if we just look at the recipe component, measuring cups are usually labeled like a half, a third, a fourth. So you wouldn't really see a decimal used for recipes. Similarly, dollars are always measured in decimals. You would never really measure 1/6 of a dollar or 1/3 of a dollar. They're always written as decimals. So it's important we know both decimal forms and fraction forms because both of them have their own individual uses depending on the situation. Okay? So, based on what I just said, I want you to fill out example 1. I want you to describe in your own words why we would need to know how to represent rational numbers in different ways. So why would we need to know fractions and decimals? So take a second and go through that and then check back at the video before we move to example 2. So hopefully you just came up, I'll come up with like my idea. Hopefully you came up with something similar. So different situations in the real world require different representations of rational numbers, okay? Because of common usage in life outside the classroom, we may automatically know that a quarter of a dollar is the same as 25 cents or a quarter, right? But for people who are used to measuring money in only decimals, a quarter of a dollar might not make much sense. All right, so I went the route of thinking about money. If you don't know your fractions, for instance, and someone says a quarter of a dollar, you may not know that means 0.25. It's very important that we are flexible with this. If you're cooking, for instance, I could have wrote this down. If it says a third of a cup and you have no idea what that means, you may be out of luck there. So it's important to know all forms of rational numbers. Now, we're going to take a look down here at example 2. I'm going to go through this step by step. So make sure you're taking notes and listening as we go through. So what is the value of the number 2 and 25/100ths? How can this number be written as a fraction or mixed number? So this is 2 and 25 hundredths. And I'll actually write that out in words, 2 and 25 hundredths. Now, as a mixed number, you have the whole number of 2, and then you have 25 hundredths. Now, if we want to go and convert that into just a fraction, you can multiply the whole number by the denominator. You get 200 and add the 25. It would be 225 hundredths. 225 hundredths. Okay? That should be a review. Okay? Now, B, rewrite the fraction in its simplest form, showing the steps. So I'm going to write this fractional part of the mixed number, the 25 hundredths, in its simplest form, showing the steps. And I'm going to show this in 2 different ways. So one way I can do this is I can find the greatest common factor, which I know is 25, and I can divide my numerator and my denominator both by 25, and that would get me 1/4, which is as simple as it can go. So the whole number, the entire number, would be 2 and 1/4, or 2 and 1/4, because you still have this whole number of 2 in front, right? Now, another way I can look at it is I can just break apart this denominator. So if I have 25 hundredths as my fractional part, with 2, of course, being the whole number, I can break my denominator up. And how I can break that up is I can have 25 in my numerator, and my denominator is the same as having 25 times 4, because having 25 4 times gets 100. Now, what happens here is these divide and get 1. So you're left with 1/4. So our ultimate answer, once again, is 2 and 1/4. Either way, strategy 1 or strategy 2, we end up with this simplified mixed number of 2 and 1/4. Okay? Now let's look at C. First of all, this number is not equivalent to this number. It is different to add a 0 at the end as opposed to adding a 0 in the middle of a number. This number is actually, and I'll write this out, 2 and 25 thousandths, because that 5 is in the thousands place. And if I'm going to write this as a mixed number, it is 2 and 25 thousandths. There will be 3 zeros. What I like to do, if I'm trying to figure this out, the number of numbers after the decimal point, there are 3 numbers after the decimal point. That tells me I need 3 zeros in my denominator. Okay? Now, I'm going to rewrite the fraction in its simplest form. Now, I'm going to focus on just the fractional part. Keep in mind, I still have that whole number of 2. Now, once again, I can use 2 different strategies. I know the greatest common factor here is 25. So I can divide by 25. 25 divided by 25 is 1, and 100 divided by 25 is 40. Now, how I got 40 quick is I knew 25 went into 100 4 times, and I added that extra 0. So the mixed number here would be 2 and 1/40. All right? Now, another way I can look at this is how I looked at it up here. We can take our 25 thousandths and I can look at breaking up the denominator. Now, the denominator can be written, and I'm going to keep that 25, but it can be written as 100 times 10. right? Because 100 times 10 gets 1,000. Now, if I want to break that up even further and keep my 25, the 100 can be written as 25 times 4, and then you still have that times 10 from over here, right? Now, what happens, these get 1, and then our denominator will be 40. So the ultimate answer as a mixed number is still 2 and 1/40. So whichever strategy you felt like was easier is fine. But we have to be comfortable kind of with both, because oftentimes using one strategy is much more productive than using the other, especially if, for instance, if you're trying to use strategy 1 and you're not sure what the greatest common factor is, using this second strategy may be quite helpful to you. So, considering the strategies we just learned, what I want you to do, and you're going to stop when you get to example 3 down there, is convert these 4 decimals into fractions, but the key is I want you to simplify it, okay? So, write it as a fraction and then show the steps that you use to simplify it into its simplest form. Once you are done with those 4, come back and check the video before we look at example 3. Exercise 1 here, you see my strategy to get these 4 decimals into their simplest form. If you used a different strategy, that is 100% okay. Your key is to just focus in on the circled part. Make sure you simplified it down to its simplest form, which I have circled in red. So pause that and check to make sure you have those correct. Now, what we notice about all of these is all of the denominators, when we originally take our decimals into fractions, is that the denominators are all powers of 10. Okay? And you need to keep that in mind when we get down to the next example, which will be defining what a decimal is. So with example number 3, we're going to look at this question. What are decimals? So what decimals do is decimals specify points on the number line by repeatedly, meaning over and over again, dividing intervals into tenths. If a unit is divided into 10 equal sized pieces, one piece would be 1/10 of that unit, right? And that's what's happening up here. When you're moving over in decimal places, you're basically cutting something into an additional 10 pieces, which is why our denominators here are always out of a power of 10, because we are repeatedly dividing intervals into tenths. So for B, I'm going to use that meaning of decimals, which means to split up into tens, into 10 interval sections, to relate decimal place and value. Each place value in a decimal is 1/10 of the value of the place to its left. This means that the denominators of the fractions that represent each decimal place value must be powers of 10. So, each place value, every time you move to the left, you're getting 10 times larger. But if you're moving to the right, you're taking 1/10, because something to the value to the left is 10 times bigger than the value to its right. Now, if I want to write this as a decimal, really how I write fractions as decimals, especially when their denominator is a power of 10, is I just write it how it's written. This is 3/100ths. So that is a 3 in the hundredths place. Exactly like that. Now, I'm going to describe my process here. The decimal form is 3/10. The fraction includes a power of 10, specifically 100, as its denominator. The value of the second decimal place is 1/100th, so 3/100ths in decimal form is written as 3/100ths. Okay? Now, if I'm going to look at D, and my goal is to write 3/20ths as a decimal, what I can do, and I'm going to show the process, is I can take this and I can just transform this to have a power of 10 as the denominator, right? I can multiply the numerator, sorry about that, and denominator by 5. Now, that's going to get me 15 over 100. Now, I can write that easily as a decimal because my denominator is a power of 10. This is written as 15/100ths, like that. Okay? Now, I will also describe it in words for those of you who need the practice here. The denominator is not a factor or not a power of 10. To arrive or to allow the denominator to be a power of 10, you can multiply both the numerator and denominator by 5 to get 15/100ths. 15/100ths as a decimal is 15/100ths. Okay? So basically the strategy we're getting here is to try to get your denominator to be a power of 10. Let's look at this next one. If I have 10/25ths, if I just multiply this by 4 over 4, which is 1, keep that in mind, we're just multiplying by 1, you get 40 in your numerator, and you get 100 in your denominator. So that is equal to 40/100ths, or 4/10ths. Keep in mind, these zeros can go away here, so this can also be written as just 4/10ths. Okay? Now, this bottom one, F, this is a little bit trickier because the 40 here cannot be easily multiplied to get to a denominator of 10. So watch what I'm going to do here. Try and stick this out. Now, 8/40ths, I can write 8 as 2 to the third power. What that means is 2 times 2 times 2. That gets 8. Now, what I can split my denominator into is 2 to the third power. 2 times 2 times 2 gets 8. And then 8 times 5 would get the 40. Okay? Now, what happens here is a bit complicated, and I'll write this out in expanded form here. But this can be written as 2 squared times 2 over 2 squared times 2 times 5. Okay? Now, the reason I didn't just cancel these out is because, remember, our goal is to get a denominator that is a power of 10. And if I just cancel these out, you'll be left with a denominator of 5. These can now go away. You're left with 2 in your numerator, and 2 times 5 is 10. So this is read as 2/10, meaning I can write this as 2/10. All right? So that's a little bit complicated, especially introducing those exponents in. But for sure, our goal is to understand if we want to go from a fraction to a decimal, it makes it much easier if you can get a denominator with a power of 10, because then basically you just write the decimal as you would read the fraction. With that said, I want you guys to handle here exercise 2, which is asking you to work backwards from what exercise 1 asked you to do. Exercise 1 gave you the decimal. It said go to a fraction. Here we're taking the fractions into decimals by using this idea of equivalent fractions. So remember, your goal is to get your denominator to be a power of 10. So that's either 10, 100, 1,000, 10,000, 100,000, and then use that to convert to a decimal. If you get stuck, go back and look at what we did here with this example. But once you're done with these 4, come back and check the video to make sure you have the right decimals, and then we'll start taking a look at the problem set. So for these exercise questions, B and D should have been pretty straightforward. So we're going to look at those first. B, you should have got 1 4/10. Basically, for B, I wanted to get 5 to 10. You multiply by 2, and 14/10 is the same as 1 4/10. Okay, you can convert that improper fraction into a mixed number. For D, that's even more straightforward. You multiply by 2 to get a denominator of 100, and then it can be, so if you multiply by 2 and get a denominator of 100, the zeros you would get 70 over 100. Those zeros cancel out. You get 7/10. What you see here is the kind of exponents approach here to get to 7/10. But hopefully you got to 7/10. Now, A and C required your use of exponents. So these were much more challenging. If you used a different strategy to get there, that's 100% okay as well. But you should have used some kind of equivalent fraction approach here. For A, you should have got 1,875 10,000ths. And here you should have got 34,375 100,000ths. Now we're going to look at the lesson summary here. You can convert any terminating decimal, so that's a decimal that ends, into a fraction using just place value. Basically, read how the decimal is written and write it as that fraction. This number, for instance, is written as 35/100ths, so you write it as 35 over 100. Now, you can convert any fraction to a decimal easily by just making sure you can get that denominator to be a factor of 10 or a power of 10. So I want you to go through, answer these 3 problem set questions. Pretty straightforward. If you need an extra sheet of paper because of the limited space, please do so. Then come back and check the video, and that will wrap up this lesson. So we're going to take a look at 1 first. For A, you should have got 2/5. B is 4/25. C is 5/8. Keep in mind, these are simplified. You should have simplified them. Right there, the directions. 800 is 2/25, and 12,000 simplifies to 3 250ths. Now, 2 asks us to work the other way, go from fraction to decimal. 4/5 is 8/10. 3/40 is 75 thousandths, 8 200ths is 400ths, and then 3 5/16. You can see the number here, that is 3 and 3,125 ten thousandths. So just check through those, make sure you have them correct. If you don't, fix them and go back and make sure you know how to get there or ask a question. All right. Really, 1 and 2 are the keys for the lesson. You need to be able to convert from a decimal to a fraction and the other way around. Remember at the beginning page where we were on the I know I got it statement, this is how you know you got this. You can convert from a decimal to a fraction and the other way around. Now, for number 3, Tanya can finish the conversion since they're factor pairs of 3 in the numerator and denominator that can be divided out with a quotient of 1. All right? So, to finish this problem out, which is what you see over here, 2 to the third power, 2 of those, or 3, these 3 3s cancel here, and you're left with 2 2s down in the bottom. This 3 cancels with one of these 3, and you're left with this 3. Now, I'll write this out in expanded form for you guys, because you may be like, what in the world's going on? So, if I have these, that is 2 to the third power. This is 3 to the second power. Okay? Then I have 2 to the fifth. So I have 1, 2, 3, 4, 5 2s. And then I have this 1 3. And then I have this 1 5. So what's happening here is these are dividing to get 1 over and over again. Okay? So we are left with the 3 in the numerator, which is what you see here. You have 2 to the second power from those 2 2s that are left over. Then you have that times 5. So this work here shows how we got from here over to here. Okay? Then if we multiply by 5 over 5, which is just 1, you get here 3 times 5 is 15, and 2 squared is 4. 5 squared is 25. 4 times 25 gets 100. So you get 15 hundredths, which is just written as 15 hundredths. Okay? Now, 3 is a little bit of a challenge, but for sure, if you have this lesson, you should have been able to do 1 and 2 pretty fluently and accurately. If you were able to do that, you're prepared to move on to lesson 14.